Hopefully. There we go. All right. So today, continuing on into 5.2 with trig identities. What we do today is going to involve something called verifying trig identities. And so what we're going to end up doing is, it's more like what we did yesterday, simplifying expressions, but with a goal of what we want it to simplify to and everything. Our goal will be to make both sides of the equation look like each other. So with that, go ahead and grab your notes. And we'll go ahead and get started. So 5.2, more trig identities. And whenever we're working with trig identities, it's a good idea to have your trig identities written down somewhere. So just to remind us really quick, we had the reciprocal and quotient identities. Which were sine equals 1 over cosecant, cosecant equals 1 over sine, cosine equals 1 over secant, secant equals 1 over cosine, cotangent equals 1 over tangent, tangent equals 1 over cotangent, cotangent equals cosine over sine, and tangent equals sine over cosine. So those were all of our reciprocal and quotient identities. And then we also had the Pythagorean identities. So that was the sine squared plus cosine squared equals 1. And then if we were to divide through by sine, we would get 1 plus cotangent squared equals cosecant squared. Or if we were to take this and divide through by cosine instead, we would get tangent squared plus 1 equals secant squared. And then we had all kinds of rearrangements of those as well, but those were the main 3 Pythagorean identities. Okay, so it's good to have those written down so that we have them nearby when we're solving trig identities here. Our first example for today is going to be an example of what we're going to call verifying trig identities. So we're going to be given something like this: cosecant squared minus 1 over cosecant squared equals cosine squared. And we want to show that this side is equal to this side, because just written like this, it's not immediately obvious that the sides are actually equal to each other. So we want to simplify this side or simplify this side until they look the same. And there's a couple different ways that we can do this. Generally speaking, there's going to be more than one way that you can simplify these. So for this first one, and actually kind of as a general rule, if you try something and it makes it more complicated looking, then you try something else. And, you know, just kind of, it's a bit of a guess and check process. After you start getting used to these kinds of problems, you'll see that it gets a little bit easier to predict whether or not something is going to make things simpler. But anyway, starting with this one, I would do something similar to what we did on number 7 on the homework that we had just been talking about. I would split the top. So I would turn this into cosecant squared over cosecant squared minus 1 over cosecant squared. Then we can notice that, hey, this is 1, and 1 over cosecant squared is actually equal to sine squared. So we get 1 minus sine squared. And then if we take our Pythagorean identity, sine squared plus cosine squared equals 1, and rearrange it a little bit, we get that cosine squared is equal to 1 minus sine squared. So I can take this and notice, hey, these are the same thing. So I'm going to take this and replace 1 minus sine squared with cosine squared. And then we get down to cosine squared equals cosine squared, and that's when we know that we are done with the problem. So again, the goal with these is to get down to something like this, where you get the same thing on both sides by manipulating one side or the other side or both in order to simplify. Any questions from this one? Anything we're not sure where it came from or aren't completely convinced that we can do that substitution? All right, then let's try another. This time we're going to have cotangent, secant, cosecant squared minus cotangent cubed, secant equals cosecant. All right. So something like this, just in a lot of cases, there are multiple routes you could take. Sometimes it's helpful to factor things out. Like if you notice a greatest common factor amongst your two terms over here, you can factor that out and see what that leaves you with. So we're going to try that on this one. So on this one in particular, I noticed that we have cotangent times secant in both of these. So I'm going to pull out a cotangent times secant. And so in the first term here, without cotangent and secant, we're left with cosecant squared. And then over here, we're left with one less cotangent and no secant. So we're left with cotangent squared when we factor that out. Oops, that's not a cosecant squared, that's just a cosecant. We're just dropping that one down. All right. Then what I might do is notice that from our Pythagorean identity, we had 1 plus cotangent squared equals cosecant squared. So if I rearrange, we get 1 equals cosecant squared minus cotangent squared. So that means that this thing is 1. So we're really left with cotangent times secant equals cosecant. Then I might try putting things into terms of sine and cosine. So cotangent is equal to cosine over sine. And secant is 1 over cosine. So then we can have the cosines cross cancel, and we're left with 1 over sine equals cosecant, and cosecant is equal to 1 over sine. So we can put cosecant equals cosecant. And then we're done because we got down to where they're both equal. Okay. Any questions from this one? Any numbers we're not sure where they came from? Any steps we're not sure how or why they happen? Good question. Cotangent was cubed, but then since we factored out a cotangent, it had to reduce in power by 1. So when I factor out the greatest common factor from both, we have to take a cotangent and a secant out of both of them. Awesome. Yeah. Good question. And when, yeah, factoring with these can get a little bit confusing sometimes. So we are going to do actually a couple of examples of just factoring with these. How did you know what to do for the first step? That's a good question. It's one of several first steps we could have taken. You could have started by trying to turn everything into sine and cosine for this and see what cancels and stuff like that. So knowing what to do for the first step tends to be the hardest part for a lot of people. And a lot of times it's just trying something. And then if it makes it better, continuing on with that. And if it makes it worse, going back and trying something else. So, I mean, I tried that as the first step because I'd already tried a couple of different things on this particular problem before trying that as my first step. So I knew, I guess, kind of where I wanted to go with it in the problem. Let's see. Let me think, see if we can get it to, see, that would be, you could try instead for a first step, if you wanted to try changing everything into terms of sine and cosine first, you could. And kind of see where things shake out. Actually, let's try that really quick. That might be kind of fun. Let's do an alternate solving of it in the way that's a little bit more like the way that you might typically think of doing the problem. What if we turn everything into terms of sine and cosine on the left-hand side? So we'd have cotangent is cosine over sine, secant is 1 over cosine, cosecant squared is 1 over sine squared. So we would cross cancel the cosines, and for that term we would get 1 over sine cubed. And then here cotangent cubed is cosine cubed over sine cubed. Secant is 1 over cosine, so that would become a squared, and you would get cosine squared over sine cubed. And then these are common denominators already. So you would get 1 minus cosine squared over sine cubed. And then 1 minus cosine squared is equal to sine squared, because that's from our Pythagorean identity. So you could replace it with sine squared. So you'd have sine squared over sine cubed. And then 2 of your sines up here cancel with 2 of them down here, and you're left with 1 over sine, which is cosecant. Well, that was kind of fun. So that's an alternate way to solve this. Instead of factoring out cotangent secant from the first step, you could have turned everything into terms of sine and cosine and kind of gone from there. And sometimes it works out nicely, and sometimes it doesn't. A lot of times a good thing to try is, if you don't know what else to try, is to try turning things into terms of sine and cosine. That's often a good step to try out. Sometimes it makes it better, sometimes it makes it worse. But yeah. So as far as knowing what to do for the first step goes, you don't always know what to do for the first step, but you know of some things that you could try. Like see if anything factors out, or see if there's a Pythagorean identity somewhere that you recognize, or try turning things into sine and cosine and see if anything cancels nicely. So there's some good kind of options for first steps. But yeah. All right. Any other questions from that one? That one generated some good questions. Okay. Then let's try another, and then we'll talk about a different kind of problem as well. This time we've got tangent squared over 1 plus secant and 1 minus cosine over cosine. Okay. So just like the last one, there's a couple different ways that you could do this problem. I'll show one way. But yeah, again, there's multiple methods you could take. The way that I'm going to try involves taking tangent squared and substituting in the Pythagorean identity for tangent squared. So tangent squared becomes secant squared minus 1. So we have secant squared minus 1 over 1 plus secant. And then I'm also going to work on the other side. So you can work on both sides simultaneously, simplifying them. So on this one, I'm going to go 1 over cosine minus cosine over cosine. So this becomes a 1, and 1 over cosine is secant. So we have secant minus 1. On the right-hand side, this thing on the top can factor because of difference of squares. So if you remember your factoring from advanced algebra trig, is probably your favorite thing. The factoring, this is difference of squares here. And so difference of squares was where you put the plus in the middle of one and a minus in the middle of the other set of parentheses. And then the first thing, the square root of it. So you get secant in the first part of both boxes, and then 1 in the second part. And then something nice happens here because secant plus 1 cancels with 1 plus secant because those are the same thing. So we are left with secant minus 1 equals secant minus 1. Yeah, we can make a list of some possible starting options. Another way that you could have started this one was you could cross multiply and see what happens. In fact, if I was going to try this to do this one again, that might be what I would attempt, cross multiplying and see what goes on. The only hard thing about making a list of things that you can start with is that whatever list we make is probably not going to be exhaustive, because there's a lot of different starting options. You can check for Pythagorean identities. You can try to factor out a greatest common factor. Or just factor in general. Let's see, what else can we do? We can put things in terms of sine and cosine. Occasionally you could cross multiply. Let's see, what else? You can split apart a fraction. Like we did over here. You could do the opposite of that. You could make a common denominator. I don't think we have we learned about multiplying by the conjugate. I don't know that we have, but sometimes you can multiply by the conjugate if we run into a problem where that's the most applicable thing to do. I'll talk about that separately. But that's a good list to get us started, right? A bunch of different things that you could try doing depending on what you think makes most sense given the situation. So yeah, that's a good list of options. Okay, so the last thing we want to do today, or the last kind of problem I want to introduce, is just more of a factoring kind of problem. So with sine, cosine, and tangent, we've already seen right here where you can factor an expression, and we need to be able to recognize things like difference of squares or situations where we might be able to factor and cancel stuff. So we're going to do a couple of examples of factoring with sine, cosine, and tangent. So yesterday you saw multiplying with trig and getting things that you might factor later on. Now we're going to undo the multiplication and factor. So first example for factoring. This one will be pretty simple. We'll start easy. Cosine squared minus cosine minus 6. Okay, and so this works pretty much the same as you would factor if you were using something, if you were factoring something like x squared minus x minus 6. In fact, it's so much the same that you can use this and then substitute cosine in for x at the end if you really want to. So if you can remember how we factored before with quadratics and whatnot, we're looking for things that multiply to -6 and add to -1. So that would be -3 and 2. And then if I was factoring this, we would get x minus 3, x plus 2. Well, the same thing happens here with cosine, except instead of having x minus 3 and x plus 2, we get cosine of x minus 3 and cosine of x plus 2. So if you want to take whatever trig function you have and substitute x for it instead, and then put the trig function back in at the end, you can, if it works better in your brain to factor that way. Usually does for me. Makes it a little bit less messy looking. So let's try another one. We'll do a different kind this time, not one where it's a coefficient of 1. Let's do, we're going to go 9 cosecant squared minus 12 cosecant plus 4. Okay. So if I'm doing something similar to what I had done in the last one, I might go instead 9x squared minus 12x plus 4, because that's a little bit easier to think about factoring. So this was the kind where you factor by grouping. So we go, okay, 9 times 4. And then we're looking for things that multiply to 36 and add to -12. So let's see. Maybe -6 times -6. So then we have to rewrite it. We get 9x squared minus 6x minus 6x plus 4. And this is the kind where you then split it down the middle and you take out the greatest common factor from each side. So here it's 3x. We get 3x minus 2. And then here it would be -2. And then we get 3x minus 2 times 3x minus 2. So then, putting it over here, instead of x, we're going to replace it with cosecant. So we would get 3 cosecant minus 2 times 3 cosecant minus 2. And if it works for you still to think of it in terms of, okay, I'm just going to multiply 9 and 4 and then rewrite it even with the cosecants in it, you could still do like, 9 cosecant squared minus 6 cosecant minus 6 cosecant plus 4. Split that down the middle and take out the greatest common factor and end up with this. If it works for you to do it that way and it doesn't get too jumbled or messy or anything, feel free to do it. If it works better to think of it with x's instead and then put the cosecants back in at the end, then go for it. Okay, then let's do one more. We'll do one that has more than one trig function involved. I think. Yeah, let's do that. We'll do cosine squared tangent minus 2 cosine tangent minus 3 tangent. Okay, so on a lot of the ones where there's multiple trig functions going on here, you can start by factoring out a greatest common factor. A lot of times we forget about that step until we're left staring at it and not really sure what to do. So what I might do here first is notice they all have tangent in them. And so first I might factor out tangent. So we're left with cosine squared minus 2 cosine minus 3, and then tangent on the outside. So for this one factors the same way that example 1 did. So go ahead and finish factoring this one, the cosine squared minus 2 cosine x minus 3. And when you think you've got finished factoring there, type got it in the chat. If you started off by going x squared minus 2x minus 3 and factoring that, that might be a good choice. Because then we just end up with tangent of x times cosine of x minus 3 times cosine x plus 1. Okay, so doing problems like this with factoring is going to help us later on when it comes to things like this up here when we did secant squared minus 1 and we had to factor it so we could cancel it with 1 plus secant. So, bit of a review of factoring there. Any questions from any of those three? Any numbers we're not sure where they came from or steps we're not sure how they work? Okay. Then I'm going to have you guys try a couple of verifying trig identities, and then we'll get the assignment. All right, so last part here, you try. First one, we have cosine equals cotangent over cosecant. Second one, we have 1 over tangent plus secant equals cosine over sine plus 1. Go ahead and try both of those, verifying to get them down to the same thing. When you think you've got them, or you've gotten to the point where you can't do any more, put done in the chat.
The last one that went through. That was hard afterwards.
Yeah, you mean to unmute? If you're not sure where to start, your hint for number 1 is to change things in terms of sine and cosine. That's something that will work. Your hint for number 2 is to try cross multiplying. If you want to check your work on number 1, I've got one possible method of solving it written down for you there. But there are other methods that would work. If you multiplied by cosecant on both sides and then turned everything into terms of sine and cosine, that would also work. And then on number 2, that's what I personally would do for the first step. Give that a try, see what helps there. Maybe distribute next. And then maybe change everything in terms of sine and cosine. So if you're looking to check your work on number 2, that's what I did. But again, you could have tried something else that might also work. Okay, so at this point, I'm going to post the homework, and then you'll have a couple of options. You can stay on here, and we can go over more examples together, or we can do certain problems off of the homework together if you would like, or you can work on your own. We'll also, I forgot to show the key to the homework, so we'll go over the answers to last night's homework as well, real quick, before everyone leaves.